Hey everyone, welcome to class 124. We're going to talk a little more about series and parallel circuits today, and specifically how their resistances, or their equivalent resistances, differ, like the total resistance of the circuit. After this class, we're going to start looking more at circuits and analyzing them as a whole. All right. So just from last class, this was your exit ticket from last class. We have a 12-volt battery, and we know that 3 amps are going through the battery, okay? So we know in a parallel circuit that the voltage is the same in each branch. So this is 12 volts, and this is 12 volts. We also know that in a parallel circuit, due to the junction rule, the current splits. So if we think about it, 3 amps comes out of the battery, so we have 3 amps here. Okay, the question is basically how many amps go this way? Well, how many amps go this way? We know it's 1 amp, right? 1A, sorry, there's a little overlapping there because we see the 1 amp right here. So how many amps are going down that middle branch? Well, current in equals current out. If 3 amps are going in and 1 amp is coming out over there, well, we have to have 2 amps going this way, so this has to be 2 amps. All right? Now, in a series circuit, okay, current is the same everywhere. So if it's 2 amps through this resistor up here, it's 2 amps here, and it's 2 amps here. But now, in a series circuit, the voltage is the thing. The voltage through each resistor has to add up to the total voltage. Just like the current here has to add up to the current total. See, 2 and 1 give you 3. In a series circuit, the voltage has to add up. So 5 plus what gives us 12? That's 7. And there you have it. So you're going to build a couple circuits. Click on that link there. It's the same simulation we used last time. You're going to click on intro. So you're going to make these 3 circuits. Give yourself some room. They're all identical, basically. I just kind of turned them all different ways. But basically, 9-volt battery, 10 ohm resistor. So make those 3 and then unpause the video. All right, so hopefully you have those circuits. And it says, using the ammeter, measure the current through the battery of each circuit. Okay, we call that the equivalent or the total current whenever you're measuring it through the battery. Okay, that's kind of like the powerhouse, the beginning and the end of every circuit. What conclusion can you make about the equivalent or total resistance of each circuit? So let's look, that's interesting. So we have to use the current to make a comment about the resistance. Well, we know how to do that because we know how they're related. Let's see, the current here, 0.9 amps. Current here, 0.9 amps. Current here, you guessed it, 0.9 amps, all right? So the current is the same throughout all of them. So if the current is the same throughout all of them and they have the same components, we can assume that the resistance is the same throughout all of them. All right. So current is same. Therefore, resistance is same. Now, what do I mean by the equivalent or the total resistance of the circuit? Well, we're going to see right now. So when you start adding more resistors to the circuit, each resistor has its own individual resistance, but those resistances add up, if you will, to give you an equivalent resistance. Okay, we're not really going to use the phrase total resistance, we use the word equivalent resistance. So you're going to change 2 of your resistors, or 2 of your circuits. This one you're going to add a resistor in parallel, and one of them you're going to add a resistor in series. All right, so let's do that right now. Let's move this off to the side for now. So for this one here, we have our resistor, and we're going to add 1 in parallel. Just be careful when you make these that you don't connect 2 circuits that shouldn't be connected. So there's one added in parallel. This one I have to fix, so I'm going to get rid of that. I'm going to put this here. Let's see. Okay, and don't forget, all of the resistors are 10 ohms, all right? Batteries are all 9 volts. Perfect. All right, so now we're going to look at the current through each battery and make a comment on the resistance, all right? Actually, let me just double check what my wording was there. Using the ammeter, measure the current through the battery of each circuit, all right? How does the equivalent resistance change when adding resistors in series versus adding resistors in parallel? All right, let's just find the current first. It's a little wordy, but let's just look at the current. So this one's 0.9 amps. This one's 0.45 amps. This one's 1.8 amps. All right, so let's write that down just so we can kind of keep track of it. So this one has a total current of 1.8 amps. This one has a total current of 0.9 amps. This one has a total current of 0.45 amps. So how does the equivalent resistance change when adding resistors in series versus adding resistors in parallel? So before we added anything, the current was 0.9. When we added one in series, the current became 0.45. So the current went down. What does that mean happened to the resistance? Right, the resistance went up. Okay, so add resistor in series, the resistance goes up. Okay, our equivalent goes up. The total resistance goes up because the total current, or the equivalent current, went down. We don't really call it the equivalent current, we just call it the current through the battery. Okay, let's think about that again for a second. Before we did anything, when there was just one resistor, one battery, the current through the battery was 0.9 amps. When we add another resistor, identical, in series, the current is 0.45 amps. The current went down. How do we make the current go down? There's only two ways to do that. You can make the voltage less, which we did not do, or you can make the resistance greater. Well, the resistance of each resistor isn't greater. It's the equivalent or total resistance. When you put the two together, that became greater. Now let's look what happened here. Remember, when we only had one resistor here, the current was 0.9 amps. We added a resistor in parallel. Now the current is 1.8 amps, so the current went up. If the current went up, what had to happen to the resistance? Was there more resistance or less resistance if the current got bigger? All right, there's less resistance. So add resistor in parallel. The equivalent resistance, our equivalent, goes down because the current went up. Now, why is that? Well, think about it this way. Think of the resistor as, think of this as like water going around a river, right? The battery is kind of like the battery pushes the water. The resistors are like rocks in the water's path. And the wires are kind of like little canals or whatever. I know this is a little bit roundabout analogy, but just stay with me. So in this circuit, water comes out of the battery, goes through the resistor. The resistor slows down the water a little bit. If the resistor weren't there, the water would go too fast. So we have a current, think about it like water, like current, of 0.9 amps. Okay, so think about the resistor like rocks in the river. Now let's say here, we put more rocks in the river. Well, if I have water leaving the battery, and I have not just one set of rocks, but two set of rocks to go through, well, the water's not going to go as fast. The current's going to go down, okay? So why does the resistance overall get smaller here? Well, think about it this way. Water leaves the battery. It's going down the river. Think about it this way. Now the water has two paths it can go down. Half the water can go this way, half the water can go that way. So you're kind of like opening up more channels for the water. Okay? And then we come back here. So that's why there's more current and less resistance in a parallel circuit. Think about it like cars on a road, okay? If you open up a second road, then you lower the you lower the resistance. You increase the amount of the flow, the current, how many cars can go through. In this case, well, you're not opening up a second path for the current, okay? There's just more in the way to get through in that single path, all right? So these points here are really important. Just put an asterisk next to them. So it says here, find the equivalent resistance of the series circuit with two resistors. So how would we do that? Well, we know the current is 0.45 amps in that's this resistor, that's this circuit here. We know the voltage is 9 volts. So we use our equation R equals V over I. We get 9 volts or 0.45 amps. That comes out to be 20 ohms. Now, what's the equivalent resistance in the parallel circuit with two resistors? Well, for that one, the current was 1.8 amps. The voltage was still 9 volts. So R equals V over I. That's equal to 9 volts over 1.8 amps. And we have 5 ohms. Okay, so it says, number 7 says, come up with an equation for the equivalent resistance in a series circuit. Well, in the series circuit, we had two 10 ohm resistors, and the equivalent resistance was 20. How can 10 and 10 become 20? What do you have to do? You add them, right? 10 ohms plus 10 ohms equal 20 ohms. Okay, so what is our equation for the equivalent resistance? R equivalent in a series circuit, so series, R equivalent equals R1 plus R2 plus... Parallel circuit's a little tougher. How can 10 and 10 become 5? And I know what you're probably thinking, well, each resistor was 10 ohms, and there were two of them, 10 divided by 2 is 5. And you're like half right in that. It's actually a little bit more complicated, but it's a simple equation. And this is what it looks like. So in a parallel circuit, 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3 plus dot, dot, dot. So that equation is actually a little bit more harder to use than you might think, because a lot of students, what they'll do is they'll do like 1 over R1, which is 10, plus 1 over R2, which is 1 over 10. Excuse me, 1 over R1 is 1 over 10, plus 1 over R2 is 1 over 10. And they'll get 2 over 10, and they'll forget to invert that number. So here's how this one works. 1 over R equivalent equals 1 over 10 ohms. I'll leave the ohms out, plus 1 over 10 ohms. So 1 over R equivalent equals 2 over 10, or 1 over 5, right? But you can't forget to raise it to the negative 1. So R equivalent equals 10 divided by 2, or 5 ohms. Where is this on our reference table? That's not our reference table. Right here, in a series circuit, just with our other series equations. Right here, parallel circuit with our other parallel circuit equations. So our big takeaways: as you add resistors in parallel, you open up more paths for the current. So the resistance equivalent goes down and the current total goes up. As you add resistors in series, you place more resistors in your path. Therefore, R equivalent goes up and the total current goes down. All right, just an important idea to remember. So let's just do some practice here. Two 10 ohm resistors have an equivalent resistance of 5 ohms when connected in an electrical circuit with the source of potential difference. Draw a diagram of that circuit. So, well, is this a series or a parallel circuit? Well, I don't know. The two resistors add up to be 5 ohms. Well, if it's a series circuit, R equivalent equals 10 plus 10 equals 20. Well, that's not the equivalent resistance. Let's try the other one. Let's try parallel. Parallel, 1 over R equivalent equals 1 over 10 plus 1 over 10. Now, we already did this question, so I'm not going to go through it all. So we know that the equivalent resistance here comes out to be 5 ohms. But practice doing that algebra on your own. That is a part where people get tripped up. So we know we have to draw these two in parallel. How do we do that? There's a bunch of ways to do it. I would just do something like this. That was kind of ugly at the end there. And there we have it. All right. If you drew it sideways, that's fine too. You could draw it like this. You could draw it like that, whichever way you want, but basically something like that. A combination of two identical resistors connected in series has an equivalent resistance of 10 ohms. So R equivalent equals 10 ohms. And it's in series and the resistors are identical. Okay, what is the equivalent resistance of the combination of these two resistors if connected in parallel? So we have two identical resistors, we'll call them R. And when in series, they add up to 10 ohms. So R plus R equals R equivalent. They're identical, right? So we'll just call them R. So R plus R equals 10. Therefore, each resistor is 5 ohms. That's not our answer, though. It says, what is the equivalent resistance of the combination of these two resistors when in parallel? So 1 over R, we'll leave out the 5 for now, plus 1 over R equals 1 over R equivalent, because this is the parallel equation. 1 over 5 plus 1 over 5 equals 1 over R equivalent. And I believe the R equivalent in this one comes out to be, let's see, 2 over 5, and then you flip it, 2.5? Yeah, I think R equivalent is 2.5 ohms. All right, so this stuff is not due until Friday at 8 p.m. If you have questions, stop into Extra Help. I don't think I'm going to have Extra Help Friday at 3:15 this week, but I will be available in the morning. I'll post about that, though, all right? Make sure you fill out the questions on the Google form, all right?